Hello and welcome, my dear students, to the class of Software Witchcraft and Wizardry. My name is Daria Orlova, and today I will be your professor of defense against the dark bugs. But besides occasionally teaching magic at conferences, I'm also a Flutter developer. And currently I'm building a company called BB Apps, where we build apps that care for you and the planet, hopefully helping you making more mindful choices about your lifestyle and helping you achieve your goals. You can check out my work so far at bbapps.dev, and you can also talk to me during the conference. I'm always happy to talk about my projects. But before going my own way, I was working in agencies, building apps for clients, many different apps in many different domains. Okay, there's some magic with the lights going on. Right. Okay, and yeah, eventually, by building apps for clients, I became a tech lead. And as a tech lead, my tasks, the scope of my tasks were different, more abstract. And I was automating systems, systemizing our approaches, app architecture solutions, and so on. And obviously, I did that with the help of static analysis tools, which is also the topic of today. In Harry Potter and the Half-Blood Prince, students throughout their potions class were brewing a potion called Felix Felicis, also known as liquid luck. A sip of that gave drinker a spell of luck, and anything they attempted would be successful. So inspired by that, I decided that Felix Felicis is a great analogy to what we will be brewing today, and that is a robust and automatic static analysis system. And just to keep it a bit more fun, get your questions ready because the best question will get a portion of liquid luck. Of course, to explore coding practices, we need a sample app. What I've built for this demo is an app called Magic Beast, where you can see different kinds of magic beasts. And if you've ever been to my talk or know me in general, you know that I have this thing with cats. And there can't be a talk that does not mention a cat. So the star of today is Shadow Felice, which is no ordinary cat, but a magical beast. The goal of this demo is to refactor our initial app step by step, but only by following what static code analysis tools tell us to do. And we will see how even by refactoring such a small project, these tools can be very powerful. Now let's see some code. From the first glance, we can see that the Beast page view is a stateful widget, which doesn't have any state. Our main page has a page view with children, and some formatting is off, and also the children are hard-coded. We have a separate view for a separate beast. So now let's zoom in into a particular view, our Shadow Felice view. Again, if we have some experience, we can see that trailing commas are missing, wrong media query is used, stateful widget doesn't have a state, and no counts constructors. But more, if we switch to another view, and this is another view, if you haven't noticed, we're now looking at Luminara's code. These widgets are almost identical, except for a couple of parameters. So it would be great to kind of find duplicate widgets. But while catching all of this with our eyes is a very useful skill, it is also a very unreliable one because it depends on our experience, on our mood, on the deadlines, and so on. So it would be great to have it automated and make sure that we always catch such issues. And we're going to automate it via CI. I'm going to give an example with GitHub Actions, but you can use any CI of your choice, CodeMagic, Bitrise, and so on. Actually, it was my first time using GitHub Actions for this project, so if you're also new, then welcome on board. So first, in order to create a GitHub action, we will call it audit, and we will need to create a file we will call pull request YAML in the GitHub workflows path in our repository. And what we want to do is every time a pull request is open, and also every time a new changes are pushed to that pull request, we want to run an audit. So then we need to describe some admin steps. We check out the repository, we set up Flutter, we print Flutter version. And that's that with the automated system. Now let's dive into the robust part. We will start with simple yet important things, and properly formatted code is the foundation of a clean and maintainable code base. I think there's no arguing with that. But we're human, muggles. We can forget, it happens. So to make sure it never happens, we can add an automated check. The CLI command .format set exit if changed checks if your code needs formatting, and if there are any formatting changes, it will return an error code and fail RCI. For example, in GitHub, it looks like this. We have opened a pull request, and once we did that, we can see that the audit action check started. And in case something went wrong, you will see the failing check, meaning that you need to address the issues. So we can then open the details of our action and see that check code format step has failed, which means that we have formatting issues in our code. Code formatting is great and useful, but it's just the first step. Now let's put in the next ingredient, the actual lint rules. And in order to do that, we need to create an analysisoptions.yaml file at the root of our package alongside the pubspec YAML. And you can have nested analysis options files, and then the analyzer will prefer the nested ones. And you can do that in case you need to override any linting behavior in your subpackages. Starting from Flutter version 2.3, all new projects come with Flutter lints library enabled by default. This library is updated roughly once a year and contains a list of created lints, such as core and recommended lints from Dart, and also some Flutter-specific ones. In order to enable Flutter lints, if you have started your project before Flutter 2.3, we need to include them in our analysisoptions.yaml file. And doing this will enable the lints in our projects, and the Dart analyzer will start using them. For example, by just enabling the standard set of lints, we can already see in our IDE of choice, in my examples it is Android Studio, that we have 70 issues. And most of these issues are related to the fact that we're not using const constructors. Then in our IDE, we see the highlighted code, and if we put our cursor on the correct line, we will see the description of the lint. And being able to see all of these issues from IDE is useful during development, but we also need an option to run those checks in the terminal, which we can do with the CLI command flutter analyze. And if we can do it via command line, we can also use it on CI. So our next step in the audit workflow is to add the Flutter analyze command, which we can see then in the report. The step failed because it returned warnings. Now, in order to fix those warnings, we have two options. We can fix them manually, or we can use the automated command Dart fix. So by using Dart fix apply, it will fix those issues that have autofixes enabled for them. It is a very useful and time-saving command, so if you haven't been using it before, you can start now. And if we apply it in our Magic Beast app, we can see how many issues and where have been fixed. But as I previously said, not for every lint there's a logical autofix, so most of the time we will be fixing manually and automatically. Finally, when we fix all of the issues, our GitHub action will pass and will allow us to merge. Now, taking a look at the code again, we can see that const constructors are being used correctly, but all of the previous issues are still present. Formatting is still off. We're still missing trailing commas. So maybe there's more that we can do with lints. The thing is that Flutter lints library contains only around 100 lints, the Dart recommended core and a couple of Flutter ones. But in Dart, in general, there are 219 lints available, if I calculated them correctly. Sorry if I'm mistaken. But it's an approximate amount. This is because Flutter lint is meant to be more or less universal for all Flutter projects. But obviously, different teams have different requirements, more strict requirements, and it would be great to be able to configure the lints. One way is to enable, cherry pick lints, enable the ones that you want, configure them to your needs. Which you can do, but I think that this way it's very easy to miss some lints, especially when the new ones come out. And also you can use curated packages by already established companies such as Very Good Ventures, and they're very good analysis. But some time ago I learned about it. What's that? Go away. Not welcome. Bye. So yeah, some time ago I learned about a different approach, an opposite one. So what you do is you enable all lints by default, like all of them, and then you explicitly disable those lints that are not working out for you. And while disabling them, you should also document why you're doing so and be explicit about that. Yeah, I like the more explicit approach more because this way you're not missing out on any lint and you have to understand why you're disabling one lint or another and not just missing it because you did not notice that. So in order to follow this approach, we need to create another file at the root level and call it alllints.yaml and copy paste all of the lints from the official Dart docs website. You can also use a library. I think there's a library that does that, but depending on the library is also depending on when it's get updated. So if you want instant updates, then you should do it yourself. So this is how it looks. We have an alllints file alongside analysis options. And in the file itself, we just specify literally all of the rules. Next step is to actually include this file in our analysis options, the same way we previously did with Flutter lints. And instantly, we see that we have much more hints and also warnings now. The problem with the warnings is that we have conflicting rules enabled, such as the already mentioned prefer single quotes or prefer double quotes. I did not mention that, sorry. But yeah, the prefer single quotes or prefer double quotes, because you can't have both at the same time. You have to prefer one of them. So our next step is to configure the conflicting lints. We specify them under the linter tag in our analysis options .yaml file and turn them on or off via Boolean flag. Yeah. We also need to ignore these warnings in the analyzer so that they don't flood it because we have already explicitly configured them. Finally, we can see that now we have 163 hints more, and this time they do contain missing comma warnings. We can also, I'm not sure if you can see it because they're very small, but you can see issues highlighted in our code as usual. And once we fix those issues, our code becomes much more readable. Still not perfect. We're still using inefficient media query as well as have duplicated widgets and a stateful widget that doesn't actually have a state. So our next ingredient into the perfect static analysis system is a tool called DCM. DCM, which you may have known under the name Dart Code Metrics, is a static code analysis tool that offers more than 300 unique rules on top of the standard Dart ones, as well as many other useful features, which we will now see. One thing to keep in mind that DCM is a paid tool that offers various licenses, including a free open source license, which you can obtain by applying on the website. In order to enable DCM in our project, we need to configure it in our analysis option.yaml file under the Dart Code Metrics entry. And a good starting point is to enable the recommended preset. One thing that excites me the most about doing just that is that all of the lints that you currently see on the screen are lints that show potential errors in code. So by fixing just those issues, your code base will already be much more reliable. Now, this slide is not me trying to start a holy war on best state management solution in Flutter, because obviously Flame is. So this is actually some of the libraries that are supported by DCM, which have lints for them, even libraries that shall not be named, because you never know which project you will inherit and you still want to write as safe and reliable code as possible. And it makes sense that the Dart lints don't have lints for third-party packages, but DCM is agnostic to that, and the goal of the tool is to make you efficient and productive with the libraries of your choice, whatever that might be. Now, after we have configured DCM in analysis option.yaml, we can see the warnings in a separate type in our IDE of choice. This is because DCM is a separate analysis process. It's not part of the Dart Analyzer. It's not a Dart Analyzer plugin. So it runs in parallel to Dart Analyzer. For example, now we can see that our widgets don't have a state, can be converted into stateless widgets, and that we can use a more efficient version of media query. Another issue that has surfaced is that the first class, the class name, the first class that is specified in the file is not the same as the file name. So in our main.dart file, we see that besides main function, we also have our Magic Beast app class, which ideally should be in its own file. So by following the hints from DCM, we can refactor and extract the Magic Beast app into a separate file of its own. And of course, we can perform this check in CLI by calling a command DCM analyze and providing the path. And if we call it in CLI, then we can also add it as a step to our audit workflow in GitHub. We have also added the if not canceled check, which will make these steps run even if previous ones, such as code formatting or Flutter analyze, will fail, so that we get all of the failures all at once and don't have to rerun it every time. In a similar way, we can see the report in the audit flow details. The step has failed because we have issues. Who doesn't? Some of the lints in DCM have batch fixes enabled for them, the same as like Dart fixes. So alongside manual fixes, you can also use DCM fix in the CLI. Now I want to show you an example of manually configured DCM lints. And besides just turning them on and off, we can configure to make them even more customized to our own style guides. That's not even all. We can do a lot. And here's a couple of configurable lints that I particularly like. Banned imports, making sure that we can't import UI libraries where they're not supposed to be, such as in data and domain layers. Another banning example is for classes. For example, whenever we use datetime now, we should show that we should not do that, and we should use an abstract time provider. We can control our class code layout by specifying the order of the members, as well as specific widgets method specific to Flutter. This configuration helps to structure code so that you can always find what you expect, where you expect. And there are many, many more rules. I'm not going to be showcasing all of them. We won't have enough time, even if it would be a full talk. And you can explore them in documentation. And what's more, if for Dart, new lints are available, if they're available, usually with the new Dart version, language version. But for DCM, they usually come out once a month. So DCM is more than just a linter. And we all use packages in our code, but sometimes there can be a situation that we stop using the code from a package and forgot to remove the dependency. Thankfully, we can make sure that this doesn't happen with another DCM command, DCM check dependencies, which, as the name says, checks dependencies and reports those that are unused. Obviously, we can add it to our workflow. And then in case we have left behind any unused dependencies, a check will fail until we remove the dependencies that we no longer need. In general, part of software evolution is code that eventually becomes stale and unused. It can be in form of unused methods or even whole files. For both of these issues, DCM also offers a solution, checks for unused files and checks for unused code. So we add 2 more helpful steps to our audit workflow, which will make sure that our code base never has stale code. Why? What do you want from me? That's not for you. Go away. And sorry, Magic Beast. It will fail in case we have unused files such as unused widget.dart or unused code, or both in this scenario. But unused code is one problem, and another problem is duplicate code. Especially when we talk about multiple duplications of big chunks of code. But we will see a simple example. Here we have 2 classes, Luminara view and Aqualis view. Both of them have the same print methods with the same argument, but different method names. And if we run another DCM command called check code duplication, and obviously do it via CI too, we will get a report where we will see the code duplications and candidates for refactoring. And here is a very simple example, but when the code chunks are much bigger, it can be very more beneficial for your code base. DCM has several more features, but for today I want to show you a final one. And I believe this one definitely unlocks some dark magic. We've been talking a lot about static code analysis in Flutter. And one thing that we all know about Flutter is that in Flutter, everything is a widget. So it wouldn't make sense to have widget analysis. For that, we have DCM analyze widget command with the flag show similarity and type of reporter, which can be in console, but we will take a look at the HTML one. So once we run this command, we will get a full report on our widget system. One particular table that interests me the most is similar widgets. As you can see, for each of our beasts, and we have 5 of them, the similar widget column says they're for similar entities. So let's take a look inside to see more details. The first thing is that we have a quality score, which is based on various code metrics, such as number of params, max nesting levels, source lines of code, and so on. These metrics are configurable, but we won't have time today to dive into these details. We can also see what widgets are used and how many times. And we can see the analysis of similarity of the widget tree, which in our case in 100% among the beast widgets, which is what is compared is the widget tree itself, like which classes are used, which widgets, and which parameters of these widgets are used. And this provides us with a great insight into our widget system and a solid argument for refactoring. So based on that feedback, instead of having 5 separate widgets, 1 for each beast, which doesn't really scale, we can now refactor to use a configurable and reusable widget called beastview, and that accepts parameters for configuration. And we got rid of 4 classes and made a good architectural decision that thanks to the static code analysis report. And if we forget to remove those classes, DCM will also fail because we have unused classes. Finally, the feature that is coming soon, next week, hopefully, is on top of the widget report. You can also see the result widget tree in static form. You don't have to run the code. It will be available for every widget. And it can be useful in many cases, especially when working with design systems. And you can visually track the relationships among widgets and what is used where and all of the conditions included. Now, all of this is great, but we can still have cases when not DCM, not Dart Analyzer, nothing covers it. If you have used Firebase Analytics, maybe you know what's wrong with this code. Well, this code won't be logged to Firebase Analytics because event names can be only up to 40 characters long. And if it's more than 40 characters long, it will be dropped. And I learned it the hard way. So yeah, that's why it would be great if we could see a report in our ID that Firebase Analytics max event name length is 40 characters. So please trim that. Currently, no library has this kind of lint. So yeah, it would also be great to be able to fix it. I mean, I'm not sure if trimming to the 40 characters is the best idea, but it's better than not logging it in general. And we can do that by writing a custom lint. And in order to write custom lint, we need to use Dart Analyzer plugins. The thing that you need to know about Dart Analyzer plugins is that, first of all, they're experimental. You can only enable 1 plugin per analysis option.yaml. And enabling an analyzer plugin increases how much memory the analyzer uses. And you also should not use analyzer plugins if your situation meets either of the following conditions. You use a development machine with less than 16 GB of memory, or you use a monorepo with more than 10 POPSPIC and analysis options files. So with that in mind, I want to introduce you to the custom lint library. While you can write custom lints without it, it gives a much more easier to use API and also benefits such as debugging and writing tests for your lints. And custom lint is a library by Invertase. And in order to use that, we first of all need to define our own custom lint package where we describe the lints. And then we need to use that package in our project. So step 1, we will create a project, Magic Beast Lint. It's a Dart one. And we need to specify several dependencies: analyzer, analyzer plugin, and custom lint builder. The way you define the plugin, so the fact that you are returning lint, is you need to extend a plugin base. And from there, you need to override the get lint rules method, from where you will return all of the rules available in your package. Yes, and also, So in order to define the lint rules, then we need to extend a Dart lint rule class. We will call it Firebase Analytics event length rule. And you need to pass an instance of lint code into the super constructor, where we describe the name of the lint, the problem message, and also error severity. That's that. Then we need to override the run method, where we get several useful objects, such as custom lint resolver, error reporter, and custom lint context, and we will take a look at it in a second. And finally, we can specify optional fixes in the getFixes callback. So what we want to do is we want to track the calling of the method log event and see if the argument passed to that method is more than 40 characters, and if it's so, then we want to highlight it. So to do that, we need to first of all register what exactly we're looking for, and we're looking for method invocation. We then check the name of the method. I'm sorry, I hope you can see the code. So what we check is the method name, so that it's log event, and also we check the arguments. And I'm not responsible for using this code in production, so this is just a sample code. I'm not an expert in custom lints. I just like experimenting and probably doing bad things. So yeah, use that or write your own lints at your own risk. Finally, we want the event name. We check the event name length. I'm checking for 42 characters. I'm not sure if that's a hack or if that's how it's supposed to be, but it's going to calculate the 40 characters and also the quotes because it's a string. Finally, if that's true, then we report this piece of code via the reporter, calling the method report error for offset. We specify the code that we have, the name of the lint and the description of the lint, the offset, and the length, a number of characters. Finally, when we do that, we will see this in our console. Currently, my experience is this only works in VS Code and doesn't work in Android Studio. There's an issue open in custom lint GitHub repository, so hopefully this will be fixed, and lucky VS Code users. Yeah, and it will also be highlighted in code. And what we also want to do is we want to give it a fix, autofix. So in order to do that, we need to extend a class called dartfix. Also override the method run. It has even more parameters. In a similar way, we add method invocation callback. We check if the source range is the same where we actually found the error previously. We also, next we create an instance of a change builder where we can specify priority, which also doesn't work in Android Studio. But that's not important, and also the message. And finally, what we want to do is on this fix, we want to substring the string and make it 40 characters. And we also need to return that fix from the getFixes method of our lint rule. And now we will see it as an option in the IDE. So step 2 is to actually use that package in project, and that is very easy. We need to add dev dependencies on custom lint and also, obviously, dependency on our own repository, our own package. And we also need to specify the custom lint as a plugin in our analyzer entry in analysisoptions.yaml file. We can then run it in terminal and in CI and get error reports in the CI failing our audit workflow that Firebase Analytics event name length is more than 40 characters. Now, there is more, and we won't have time for that, but some things that we have not explored. 10 more? Good, that's cool, we'll have Q&A. And yeah, so basically what we have not explored and you can explore is strict casts that are specified in the language entry in the analyzer. Entry in analysis options. Also, we can propagate and change the status of different lints from error to warning to ignores. There's also several GCM features that we have not looked at, such as several code quality checks, metrics, and dependencies graphs. There's also a lot of lint packages that include both created lints from the Dart system and also custom lints. And the thing is, a lot of them, which do use custom lints, use the custom lint library, the one that we have just talked about. And the beauty of that library is that we can use several packages that use that plugin. So it's not like, we can use only one plugin. So if we use custom lint, we can't use any other plugins, but every library that uses custom lints to write custom lints can be enabled. You can also use different extensions for your IDEs. For example, finding and use Dart files and assets in VS Code. And looking for some more better actions on GitHub. For example, what you could do is create a bot which not only analyzes statically what needs to be fixed, but also calls the DCM fix and dark fix comments and opens a pull request, for example, with those fixes, automating it even more. And you can also use a JavaScript copy-paste detector tool for finding duplicate code. So yes, our perfect static code analysis system is using GitHub Actions. And what we added is code formatting checks, analysis options, all of the lints, DCM, and custom lints. Finally, the whole audit workflow looks like that, with a lot of steps and a lot of feedback for us, helping us maintain a good code base. And that's it. I would be very grateful for your feedback, so you could please follow. It will take literally 15 seconds. It's very fast. And thank you, and let's do some questions.